Hello guys, welcome to my YouTube channel. This video is very simple, but I think it will help you to guide your module. So before we start, please pause for a moment, close our eyes and feel the presence of God. In the name of the Father, Son, and the Holy Spirit. Amen. Okay guys, are you ready? So our topic is all about graphs of polynomial functions. So the objectives: describe and interpret the graphs of polynomial functions and graph the polynomial functions. So review: direction, classify its function as polynomial or not by completing the table below. If the function is polynomial, identify the degree and the leading coefficient. Okay, so I have here the table. For number 1, it is polynomial. What is the degree? 3. The leading coefficient? 1. Number 2, not. Number 3, not. Number 4, not. Number 5, polynomial. The degree is 6 and leading coefficient is 1. Try to observe and examine how to determine or how to classify that function is polynomial or not. Okay? Look at number 2, the exponent. Okay? The exponent for variable x is 1/2. Meaning, if the exponent is not a whole number, then it is not polynomial. Number 3, if there is a denominator which is a variable, then it is not polynomial. Number 4, if there is a variable inside the radical sign, then it is not a polynomial. Meaning, there are 2 polynomials out of 5. Now, if it is polynomial, what is the degree? The degree is 3 because the highest exponent is 3. Here, for number 5, the highest exponent is 6. The leading coefficient. Leading coefficient is the sign or the numerical coefficient of the highest degree, which is 1. Number 5 also 1. Clear? Okay, so we proceed. So there are 4 cases of the leading coefficient test. So we have here the polynomial function in standard form, and I have the table. Case number 1, p of x equals the quantity of x plus 3 times the quantity of x plus 2 times the quantity of x plus 1. And this is not a standard form. This is a factored form. Now, it is very important the function is in a factored form to answer this question or the rest of the problem. Okay, anyway, we can answer using the standard form. Okay, so number 1, or the leading coefficient is positive. The positive is positive 1 because the numerical coefficient is 1. That is the sign is positive. Then the degree, add. How do we get add? Because if you are going to count the factor, 3 factors, 1, 2, 3, and 3 is add. The end behavior of the graph, okay, falls left here and rises right. Okay, so next, number 2, look at positive because the numerical coefficient of x is 1, positive 1, the degree is 4, 1, 2, 3, 4, then it is even. Look at the graph. So, rises left, rises right. Okay? So, case number 3. So we have here, there is a negative. Okay, leading coefficient is negative, and that is negative 1. The degree is add, not only the factor, but count 2. The exponent here is 1, 3, plus 2, 5. 5 is add. Then, the graph. Look at the graph. Okay, rises left, falls right. Next, for the last, okay, because we have 4 cases. So, another, we have a negative. Look at the factor. There are 4. Negative 1, leading coefficient. The degree is even. We count 1, 2, 3, 4. So 4 is even. Then the behavior of the graph. So if it is even, then look at the graph. False left, false right. Okay, I think it is clear. If it is not so, then you can download this video and review the video. Okay, we proceed to the next. Here are the steps involved in graphing polynomial functions. Write the function in factored form. Take note, factored form. Determine the end behavior of the graph of the given polynomial function using the leading coefficient test, and find the zeros of the polynomial function under multiplicity. Then if x minus a to the exponent of key is a factor of the polynomial function, then a is 0, c is key. The multiplicity refers to the exponent of the factors of the polynomial. If the multiplicity of the zeros is even, the graph touches the x-axis or tangent to the x-axis. If the multiplicity of the zeros is odd, the graph crosses the x-axis. Construct the table of values for x and p of x. Plot the points and draw a smooth continuous curve to connect the points, and make sure that the graph that follows the end behavior as found on the step above the step. Okay, so there are 6 steps involved in graphing polynomial function. Take note, there are many important that you are going to. For clear and clear, so let us have an example. Okay, so next, example number 1, describe the behavior of the graph by completing the table. So we have here factored form, degree, leading coefficient, left tail, right tail. Number 1, solution. Factor the given function using factoring techniques you have learned. Okay, so look at, observe. Okay, so why there is an x? Because both terms has an x. Then the remaining factor, we're going to factor in the using trial and error. Then the final answer we got here. For number 2, okay, the same way. So there is an x, but take note the preceded by negative, so I have here the negative. And the factor of 12 is 4 times 3 by using trial and error, and the answer is that. Negative x times the quantity of x minus 4 times the quantity of x plus 3. Now let us proceed to the degree. Okay, the degree. The degree of the polynomial function in one variable can be easily identified when it is written in standard form. The degree is the highest exponent of the function. Okay, look at here, standard form. Highest exponent. So in this case, the degree of p of x equals x cubed minus 2x squared minus 3x is 3. And the other one is also 3. Okay, so you have here 3 and 3. If there is no standard form, count 1, 2, 3. 1, 2, 3. Then the answer is 3. Leading coefficient. Okay, so the leading coefficient is the numerical coefficient. I don't forget for that word, numerical coefficient. highest degree. So the answer is 1. Okay. And other also is -1. So I have -1. So look at here. Okay. So that's why we have here -1. So the graph. Okay. So here falling at the left and rising at the right. Okay. So here answer left, right. Number 2, the graph is rising at the left and falling at the right. Okay, so I think it is clear. So we proceed. So example number 2, there are 4 examples by the way. So we are now in example number 2. Given the function in a factored form, so we have here the factored form, and you are going to complete the table by finding the zeros multiplicity of the zero characteristic of its multiplicity and behavior of the graph. Okay, so here number 1, solution of the zeros p of x, set or let p of x equals 0. So that is okay, so you have here the factor, and we are going to put equals to 0, and the answer for 1 is -2. So where do we get -2? We don't have -2 here. We have -2. Is it the answer? Okay, by the way, this is by addition property of equality. We add both sides by -1, -2 rather. So why we use -2? Because if -2 plus 2, the answer is 0. The remaining left side is x and the right side becomes -2. In a shortcut way, we transpose +2 to the right side and becomes -2. That is the shortcut. Okay, so here +1 becomes -1. +1 becomes -1, +1. Then -2, +2. That is very simple. Okay, so the zeros are the x-intercepts of the polynomial function. It is where the graph crosses or touches the x-axis. So it will determine where to touch the graph or where to cross the graph. Take note for that. Look, review the we call the steps. Okay, so next is multiplicity of 0. So the exponent of each factor is multiplicity of 0, hence that's -2 is the multiplicity of 2. Okay, where -2. Okay, we have here -2. Then look at here the exponent. Look at the exponent. The multiplicity of 0 is the exponent. So 2. Okay, here we have 3. Then here we have 4. And last is 1. Because if there is no written there in exponent, automatically there is 1. Okay, so that is very simple in multiplicity of 0. Take note only for the factored form. You cannot answer immediately through the standard form. That's why in the first step is you are going to use the factored form. So characteristic of the multiplicity. So to determine the characteristic of the multiplicity, just indicate whether the exponent of the factor is even or odd. Okay, that is very simple here. 2 is even, 3 is odd, 4 is even, 1 is odd. It is very simple. Okay, so in the behavior of the graph, just read again the steps. There is a note. So solution. Okay, in the multiplicity of the 0 is even. is means that the graph just touches the x-axis at the 0, while if it is odd, it crosses the x-axis at the 0. Okay, so even, then that's okay, negative 2 here, then add, cross at negative 1. Okay, then even, that's positive 1, add, that's positive 2. Okay, so it is very simple. Okay, you can view again this video if you want. Okay, so we proceed to example number 3. Complete the table. So here is the given, the polynomial function and the sketch. All you have to do is to determine degree and number of turning points. So this is very simple to determine the degree, the highest point, which is 4. And the turning points, we count 1, then 2, then 3. So we have the turning points. For number 2, we have exponent is 5, and the turning points is 1, 2. So we have the turning point. Now, do not count that point here, but the turning, the curve, 1, 2. So the answer is 2. That is very simple for number 3. I think it is very, very clear. So we proceed to example number 4. Make the table of values for x and p of x of the polynomial function. Okay, so you have here, then you're going to replace. If x equals negative 3, then you're going to simplify, and we got negative 64. Then number 2, if it is negative 2, then simplify, the answer is 0. Then next, if x equals to negative 1, then you're going to simplify, and we got negative 8. Then next, if x is 0, you're going to substitute. So by the way, this is not negative 0. There is no negative sign or positive sign in 0. I got a mistake. I forgot to erase this. So the answer is negative 4. Okay, so if x is 1, then substitute again, then replace or substitute, then simplify, and we got 0. Now if x is 2, simplify, then we got 16. Okay, so the next is sketch the graph of polynomial function. I forgot that I mentioned that there are 4. By the way, I forgot this is 5. This is the last. Okay, sketch the graph of the polynomial function. Okay, so solution. Let us use the steps in graphing the polynomial function. Step 1, factor the polynomial function. Okay, so the given function is already factored form. So, okay na. Then, if x intercept are negative 1, 0, 3. So, this is 0. X equals 0. X minus 3 equals 0. So, that is why we have positive 3. X plus 1 equals 0. So, transpose. So, it becomes negative 1. So, we have negative 1, 0, 3. Then, plot those values to create intervals. Okay, so the next step, the degree is 3, which is odd, and the leading coefficient is positive 1. Then the graph falls on the left and rises on the right. Then fill in the table values p of x by using x values in its interval. Okay, so you have here. So all you have to do is to substitute and simplify. Then we got the answer. Okay, so plot all points and connect points with a smooth curve. And the number of turning points is 2. Okay, so you have here. Okay, then I add number and x is 3, which is 0 because there are 3, no? So negative 1, 0, 3. So you have here negative 1, 0, then 3. So that is the x-axis. Okay, so I think it is already, we are done of this topic. So thank you so much for watching my video. So I have here the ad. With the technology already available in your fingertips, you can use downloadable apps in the graphing like Dismos and GeoGebra. This will help you in graphing polynomial functions easily and efficiently. So you can use the rather the application in your cell phone to draw the graph. Just add, you can try to use this Dismos and GeoGebra. Okay, so thank you for watching. Bye bye. Okay.